Think of making use of the symmetry in this line. You could put black king. Black king is a mate only if that is on 0 here. And then if it is, it can also be made when the black king is here, of course. But then that's, you can mirror that into that position. So they kind of collapse. So I'm wondering why this is different from, say, the king iterator. The king iterator would be just takes a king reference and then stores the reference. So why is the board iterator not taking a board? Well, it is, and then storing the board reference, period. Why do we need 4 different iterators here? I think that maybe I get it. Yeah, see, next, the board iterator next is implemented in terms of calling next on the iterators. While if, say, you look at the next operator of the king iterator, then I first create a temporary iterator and then call next on that. Nevertheless, we can do that. So creating the iterator simply means having a reference. Each iterator is only a wrapper around a reference. And then, so that doesn't do anything. It doesn't take any assembly code or anything. We just create an alias here for whatever this is. And then we call the same code anyway, where the code is then a member function of something that is more specific to what we want to do. So we can do the same thing for the board, right? So we do need those iterators, but only in the next function. So let's delete them, or let me first add the board reference then. Call that board, I guess. Which means that if I ask for a board, then I now can return a const reference to simply the board. And we store, let me keep this as well. Just store the reference. Just like all the other iterators. Let's call this board. I don't know, but it's kind of begin, but I don't know. It's so this looks much simpler. Simply creating an iterator, this means that these have a wrapper around the reference to some board. Next goes to another position on that board, so it does mutate the board. And then the next function must be implemented, whereby just make temporary iterators here. Yeah, which must be created from the same way, but then of course for the current board. So basically board dot the white king. Byte Rook. Though I don't really want to use underscores for local variables, so no, let's rename them within this function. The iter becomes just iter. Type specifier is required for all declarations. Yeah, I moved the iterator outside of the board class, so now it's called board iterator. What am I doing? The constructor is now called board iterator. And then probably get another error where I was using board colon iterator, aka this. So I have to grab the source for all occurrences of that and then change them to the new name. You stole my name. Standard iterator. Well, this is not really an iterator in the sense of the STL. It's more the English iterator. I run over all possible positions, but not really over elements of a container. Rather, it generates the next position. So these iterators are not really pointers. At least in the beginning they were not, and now they are references to something. Yeah, I don't know. It's vague. It's even confusing, I suppose, because it's called iterator. But it's no longer called iterator now. It's called board iterator. Hey. So I also don't have an pre and post increment or decrement. I just don't have that. I called it next for a reason that, yeah, less confusion, I hope. So this is the wrapper around a reference to that thing. And then if you call next, then that board is updated. It's just an interface. Really. This should compile. Oh, it doesn't. Private member. Oh boy. I still have to make it a friend. So we moved it outside the class. Hey, mushroom. Right, yeah. No, let me think. I think I really need to revamp the Rook. The Rook is now only at a single position. It just, that's where the Rook is. But let's say I call this a mate position. Then does it really matter where the Rook is? I mean, the Rook could be infinitely far down. And in fact, it cannot be here because that's not mate. The Black King would just take it. But it can be here or further down. So I want to change my Rook class to represent a set of positions, as in terms of the rook. And I'm going to display that as just drawing the rook everywhere. So I want to have the rook here and there and there and there and there, just all as if there are a lot of rooks. But yeah, well, I know there's only one rook. And then it means that if it's mate, if the rook is here or anywhere else. And that means, of course, that that's an infinite half line, basically. So we do need to know the coordinates of this square then. And then we need a direction. Let's say this is the end point of my half line. And then the half line extends in that direction. That would work. And I'm not sure we want to ever extend it in the opposite direction. I don't think that makes much sense. So if the rook is here or anywhere there, yeah, nah. Well, that would be, of course, a mate if the white king, say the white king is here, here, and the black king is there. Then if the rook is here, it's mate. But if the rook is here, it's also mate. It's just mate from the other side. But yeah, this is rather finite then. So maybe we can just treat them as separate positions. Anyways. But then again, plus we also need a quarter infinite square. Let's say the rook can be here, or here, or here, or here, and so on. The reason being that from, let's say, this and everything below it, the rook is here, and then the rook can just go up to the edge. So from this whole quarter thingy, it can move to this half line. So I need this notion. If rook is in some square, sorry, in a rectangle, possibly extending to infinity, yeah, let's only talk about extending till the edge. That means either to an existing edge or to infinity, depending on the direction. Then the only reason I need to talk about rook, let's say, it's just extremely unlikely that I need it, right? I mean, say we take this part here, this square. And I am saying that I don't care where the rook is in this square, because from this square, it can move, yeah, down to probably this line here. And why would I need that? Well, to cut off the black king, of course. So let's say the white king is here, and the black king is over here or there, and my rook is here. Then what I want to do, well, no, the rook is What does this matter? Arg, that's not simple. Is there danger that I would say compress the way we store the rook, but then lose possibility to see special cases or something? It's not super trivial. Let me just start with a board of 16 by 16 and then just have a rook just in one place. It's going to cost a lot more CPU, but well, maybe then we see the results of that and we can make a good guess for how the rook behaves and then compress it. So not storing all separate positions for all those rook, but then saying, okay, this represents all of those positions. And then I want to start with generating all positions that are made. Yeah, I'm already running over all possible positions where the pieces are within this square of 16 by 16. And I guess I can run over all of them and then determine if it is made, but it's kind of a waste because really we know that if the king is close to this edge, then the white king must be opposite and the rook must be on row 0. So we can generate those mate positions way faster than just running over everything. I'm still inclined to build in a compression, or what is the word, for the board, where if the black king is over here, then actually I'm going to store it as if it is over here, just by flipping everything in this diagonal line. Let's begin with that. It is a complication that maybe makes it harder to think about this, but yeah. So the board itself has a king and a king, which is kind of annoying because, yeah, the white king and the black king are just so different in this case. I probably just want to use a different type for them as well. Right now, the king itself is simply as a position and a color, while if I would change the type to black king and a white king, then I do not even need a color anymore. It kind of gets simpler, although we will runtime simpler, but you do get more, well, some code duplication. But the code duplication then is, I suppose, going to be going to divert, because behavior is just different, especially if I do this mirroring. And then the black king stays in a certain triangle while the white king can still go anywhere. So they're not really the same type anymore, I feel. I would also be surprised, actually, that if I would ever call color on a king. I mean, come on. The variable is probably called BK or WK. Already know the color. So I don't think this is required. Let me check that. Yeah, well, it's printed. Okay. Yeah. Okay. Yeah. Well, lame, but okay. But I'm going to split it up in two different types, I think. So the king, copy the king to white king and black king. And then same thing for the CXX. Black king.cxx. Yep. And then we edit it. So this is now the black king. I really like my types and variables to be the same, so I'm going to rename this as well. I think the white king. Now begin still give some insight, I suppose. If you do next, then well, you start with begin, and then next it gives the next one. Clearly, I could have done this with a file-wide substitution as well for the lowercase king. Let's do that for the black one. I have to take a bathroom break, sorry. I'll be back in a few minutes. was very black in. Let's flip this already true. So if the thing is on the diagonal and flip the set, then just reset flipped, I guess. And if n is less than m, because this is not true and this is true, then flip the must be false. Let's call it mirror. algorithm. Probably algorithm. Oh, loads of stuff. What is it anyway? Just Copilot not loaded. Is that all? Okay, mirror on board. To grab that. I just want a temporary mirror. If I would add a mirror to this class to board, then I would have to change flipped as well. I just don't want to do that. But board is const, so I can't even flip it. We'd have to make a copy of it, and then we can do it. Maybe call this also. Well, I don't know. Damn it. Maybe I should have called it flipped instead of mirror. Flip. Just make a copy. And then if the original is flipped, then we mirror it. and then print it. So I need to add a mirror method to the board. Definitely not const. Okay, so this just deals with skipping illegal positions. And mirrored or not, that is the same thing, right? I don't care if it is flipped or not. The power of flipping. So if it's illegal one position, then the flipped one is also illegal. So if we want to actually use the flip the boolean, then that means that as soon as the black king iterator next call passes that threshold, so the black king moves into the other triangle, then we flip it. And everything should still work. But if I must flip the whole board then in that case. So that's kind of something I should do here, I guess. And not in the iterator of the next call of the black king itself. I think this is the only place where I call it anyway. No, bullshit. theoretically, but yeah, it's only necessary if this was called. Otherwise, there is absolutely no reason to sanitize it. So if I don't know, black king moved. So if this is false, then we immediately continue, and then black king must be false, because the only thing we did is move the rook. And if this is false, same thing. If this is false, same thing. Only if all three are true, then we are going to move the rook, which then might or might not fail. So I was on the right track. We do need a split this up. This is the exact same code, but now at least I know that we're going to move the rook. So here I can set the black king move is moved to the move this here. Oh. And then after we set it, we leave it and then we test this, so that is not necessary. Can just might as well do that here. Totally works. But does it flip the board? That is the question. Let's print that as well. Yeah, that's bullshit. I just unflipped it if it is flipped. So this is never true. You just have to test the same thing as here. And it doesn't print, well, it prints 2 spaces now. Can't stand that, of course. So this is not flipped. And then if the rook moves here, then it's still not flipped because the black king is over here. We are not going to see a flip in a long time. Because then even the white king has to move till the end. Yeah, it takes forever. It takes forever. Can make it a tiny board, maybe. Temporarily make a board of 4x4. What happens? Oh, this white to play now. Okay, the king moved there, yes. And then again for the other player. And now the king moved there to, well, let's go faster. Okay, now the black king moved over here. It's still not flipped, because if it's in this triangle, I don't flip it. But if now we go around again, then the black king comes here, and then it should be flipped. That is, the coordinates are changed back to 0, 1. But we still print it as if it is there. That's what I have to check. Not sure what happened. Oh, this one was flipped. Yeah, that's not correct. What the heck is that? Okay, so do we first have black to play and then white to play? So this is at the end of playing. And the king is in the corner and the rook is, well, can't go any further. because the king is in the way. So after this one, yes, the rook resets, or the rook is at the end and then resets. The king is at the end and thus resets, so this king goes from here to there. Yeah, that's correct. But I'm not printing that. It should have been drawing the king over here, and well, the whole thing should be mirrored, I guess. Can I think of what is wrong here or not? So it's keeping a legal position. So what really happens is the rook is put on top of the king, which is illegal. Then the rook is reset because it's at the end, and the king is reset because it's at the end. So both are now in the corner, which is illegal because now the kings are next to each other. So now it's going to try to move the rook again all the way till the end, and then switch to white to play and do it again, and then we get eventually the white king on top of the black king, and then the white king comes here, and then the rook moves twice to the end, and then the white king comes after this. It comes here, still illegal, and then the white comes here, still illegal, and then the white king comes here. Yeah, and then you get this position. Except, of course, that no, at the moment that the white king is reset to the corner, then the black king should have been moved, which then is an illegal position. So the black king is here, and then the white king goes there, 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 and that's a legal position. That's this one. Yeah. Hallo Master Madou. What to do? I think having a look at the code might be a good option. Calling next. Okay, so the black king is moved. And then we call sanitize, and that doesn't work. He thinks. This gets... Yeah, I'm just forgetting to set flipped here. No. What? I think a breakpoint on sanitize should work. It's only called when the black king is being moved. So let's keep it simple and do that. Let's say initial sanitize. I still have to do this. Yeah, that's a bit too much work. I'm not calling sanitize. Yeah, no, that's true. I thought the constructor was calling it, but it's a default constructor, and sorry, that's the non-default constructor, and I'm using the default constructor. So the first time board sanitize is called is when the black king is being moved. But the black king is now moved from the corner to here. So that would mean that we are not flipped, and afterwards we are still not flipped, because this is false and this is not true. And m is unequal n. Nothing happens. So need mirror is false. Flipped stays false, need mirror is false, nothing happens. Continue. Now the king moved from here to there. So now it should be mirrored. And well, because m is 0. Oh. Oh, wait a minute. No, it's already moved, of course. So it's this is m and this is n. So if the king moved to here, then n is 0 and m is 1. Yes. And we are not flipped. And now m is larger than n. 1 is larger than 0. So we are in this triangle and we don't want to be there. So now we're going to flip the whole thing. This need mirror is not flipped. So need mirror should be true now. And flip this in advance, set to true. And then the black king is mirrored. And the white king and the rook. And then we're done. Oh, looks completely correct. I might think, I might know what could be wrong here. On a flipped board, we advance in the wrong direction. Ouch. The iterators don't work anymore. They just keep walking in this direction. And if we flip, we have to run in the other direction. But it should still print this very first position correctly. Because flipped is true. And this is like that, so it should definitely print it at n is 0 and m is 1. Black king and stuff. Okay, but we immediately iterate again. And can we move? Okay, if now I could not move the white king nor the white rook, yeah, then it would. Then it doesn't matter that the other person is still playing. It is possible that we're going to move the black king again, because iterates go the wrong way. In which case the black king is moved back, because the iterate is going the wrong way. Yeah. Okay, why would this return false or true rather? Because it's an illegal position. King is next to that king. But no, that's internal. It should just return. It should. The king should not. Plus the king is not here. The king is over here. I think. King is over here. It should just go there. Cannot imagine that the black king is going to be moved, so let's just brute force verify that. I'm setting a breakpoint at 135. That we will hit that as soon as the black king is moved again. And no, this is an illegal position, so we continue. Gonna do finish, I think. Where am I? Flipped is still true, and the black king is still at the same position. The white king is, yep, where I would expect it to be. Everything looks okay. Next. So it's just printing it wrong. No, it's just printing it wrong. No. Huh? And M is one. Yeah. Okay. I'm an idiot as usual. I simply forgot to fix this function. Yeah. Yeah, it worked. So now flip the set, and yeah, the coordinates are for the black king are printed the way they are shown now, even though it's actually stored as 1 0 and 0 2. But we don't see that anymore. It's just working the way it did before. Except that the iterate is still wrong. It's moving the wrong direction. Maybe it's not even that problematic. It is problematic. A black king moves back. That's not what you want, of course. So calling next on the black king calls actually next on the position iterator. And calling next on the rook iterator also calls next on the position iterator. Calling next on the white king iterator or the black king iterator also calls. So in the end, it's just all the same function. Namely, position iterator. This one. And that then has to walk in a different direction, which is there. This one was difficult to begin with. Yeah, plus the position doesn't know if you're flipped or not. So And maybe I should make this a different function. Nah, I'm just gonna pass a boolean that says if we are flipped or not. Then of course we have to pass that everywhere. Right, so if flipped is true, then we have to treat n and m as if they are swapped. And that doesn't make any difference for the sum. But, so if we swap these two, nothing changes. But this then changes, so I could, instead of checking yeah, it does change. Of course, vertical and horizontal limit also swap. So this must be horizontal limit in. So if not flipped, we did do whatever video. Else we do the same thing, but then with everything flipped. Yeah, I can swap this, so why not? It's quite a lot there. This is like the 101 of code duplication. So more or less. So maybe you should do it differently. Let's do it differently. I don't want to copy all this. Oh man, I have to pee again. I've been to the fitness and did drink a lot of water while doing that. It has to be purged now apparently. Zip, zip. Okay, I'll do it. Substitute pos underscore dot in in or im with star the in or im p. Right, and then yeah, that should be good. Yeah, cool. It works in the correct direction. Yes. Okay. So much for the compression of the board. You know, the blacking always sits in this triangle. Except that it still prints it as if it is in that triangle. But in the end, I think it's going to have a benefit somehow. So now it's way easier to generate all mate positions, because we just run the king over from here to there for both flipped and not flipped, except when it is at 0, 0, then we don't need flipped set. And then the white king must be on row 2, I guess. Either opposite, or if that one is at 0, it's allowed to be on 1. And the white rook is then on, well, somewhere on this line as well. Okay, bathroom break, I'll be right back. Cool. What? I never added this guy in my contacts. That's pretty annoying. Okay, then not. The usefulness of this iterator is actually zeroed. Now I did a flip thing. We must have the same horizontal and vertical limit. I am afraid. So let's call this simply limit. And this is the end coordinate of the blocking. That must be a square. So same hold cent for printing. Can keep them separate for now. Or not, let me think. Suppose I have a rectangle board. No, it's nonsense. I can just keep them. It's only important for the generation of this. Let's ignore the mirrored position. So the end coordinate of the blocking simply runs till the horizontal limit. And then I can create a blocking position. Just to create a border immediately. Hell, let's just push it. That's it. That's gonna start at 1, I think. So the black king at 0, 0. And the white king at 0, 2. What does the bloody board constructor look like? Black king, white rook to play. Oh, the old... And plays back is all nice and dandy, but it doesn't know the type of the arguments then. So you pass just the arguments of the constructor, but the constructor itself knows that these are positions, so it would accept an initializer list at that constructor position. But if you use mplace back, it doesn't really know what the types are, so you have to pass the correct type. Horribly annoying. I mean, it is not even a position actually, but it can be constructed from a position. Apparently, you can't pass an initializer list. They're really weird. Oh, it is a position. No, okay. 3 positions and a color. Well, this is also not a color, that's a color type, but the color can be constructed again from color type, so hopefully this works. Otherwise we have to pass a color as well. No, this for some reason works then, so it's weird. So this is the n coordinate of the rook. I'll just call it the white rook, I guess. Can I do that? No, I should use the print. Yep, so this generates the mate position where the king is in the corner, and then the white king must be here or on a knight's jump distance, and the rook can be either here or there. And I think these are indeed all the possible ways with the black king in the corner, except of course the mirrored one. To ignore that as well. Mirrored in this diagonal. Maybe 4 is a little bit too small now. Let me make it 4, so well 5. No, by default, this is just the vertical limit. Cool. Right. Let me. Yeah, in this case, not even the black king anymore. Then it's both the white and the black king in position, the n coordinate. So the king in, and the white rook coordinate in this case runs from, well, actually everything except when it is next to that. Everything being just start at 0. And then if we do it, where the if means that the distance is larger than the absolute value of something is larger than 1. So it can't, the black king can't take the rook. And that is then the absolute value of that minus that. So with the king here, that one must be opposite. And the rook can be here or there. Totally correct. And the king is here, that must be opposite, and the rook can be there or on the other side. And here we have that again. And here we have those three. Yeah, so the board continues on the right side, right? So the white king cannot be here because then you just walk away. So this looks okay. And then if I want to have all of them, I also need the flipped versions. And I can flip absolutely everything except, of course, when the king is on 0. Because yeah, if you don't flip it, I don't want to flip that. This is unflipped triangle, including the main diagonal. So in order to get the flipped positions, can I specify whether or not it is flipped? No, not nonsense. I just constructed that for each of these. We can construct the exact same thing but then mirrored. Maybe we should just call mirror on it. And that totally did not work because the king is here. Oh yeah, if you call mirror flipped is the flipped is set, so it's still printed like this. It is not how we should do it. I just have to set the flip it. Or I can allow flip to be set as part of the constructor. So that would be a board constructor. The board constructor now needs to accept a flipped boolean. Wait, there's a default constructor. This one, call it to play, comma boolean flipped, which I make false by default. Yep. So now we get this one and then the exact same thing, but then flipped. So the coordinates are the same, but well, I do flip them, well, I print them as well, but internally they are the same. And the flip bit is set. And then we have to generate all the positions that actually black to play. Yeah, of course, black to play in all cases, because then black is mate. White to play, it would be illegal position. So now I want to generate from all of these the positions that allow me to give mate in 1. That means it must be a position that is not equal to one of these, but after doing a single move it becomes one of these, or it can become one of these. Interesting question. Is it possible that there are 2 positions that lead to one of these? One and the same? I don't think so, because the last move must be a rook move, and if the rook is moved, then it is true, of course. It was actually a dumb remark. So this rook could, for example, be here, but also there, or there, or there for that matter. So everywhere here. Take the flipped on. It can highlight it. If the rook is here, anywhere here, they all can go to this position. Now, what I wanted to ask was, is it possible that there is a position where we can go to a single position and then we can choose between 2 moves, and both moves lead to the same position that is made? It's nonsense, right? Totally nonsense. Yeah. What if you move one piece, then it's no longer where it was, and if you do another move, then that piece is still where it was. If you move another piece anyway. So the position is not equal unless you move the same piece, but then it also has to be moved to the same spot. En passant and promotion, well, they're not relevant here, but even those do not change that fact. Yeah, so it is exclusively in 3. These are the nodes, and then from each of these nodes we have a number of positions, 1 or more, probably more, that are new nodes, and nodes that are linked to this position are not linked to any of the others. So it's just a tree. So it's just some here, and some here, and some here, and some here, and then all of these nodes again, new positions, etc. There's never a loop. Is there? Well, actually, it should of course be possible that you do one. So the next one could be a position where we either move the king and then end up there. So we move the king and then we move the rook, and then we are here. Or we move the rook first and then the king. And that's not possible in the case of a king plus rook. But if you go even further, then yes, that is possible. Or you can move the rook twice, of course. So the rook was here, then you can move the rook there. Let's say the king is... let's pick this one. Rather, let's pick this one and assume that the king is here, the black king. And the rook is over here. Yeah, but then we give mate 1. Why would I do an in-between move? But we can put the rook here. So the rook can go, so the black king is here and the white rook is here. Then I can move the rook to there, or there, or there. But you still don't get the same position then. The next move is perpendicular. Interesting. All this talk about, oh, we have almost reached AGI. Well, let's ask this question too in AI and see what it answers. And then you get something. You get some pure bullshit. We don't have AI yet. No way. Can't even if a computer that calls itself AI can't even play chess. And there is something seriously wrong, if you ask me. Okay, let's ask it. I want to see what it answers. Yeah, I don't want to tell it that. Let's make it difficult. So like this. Can a tree have loops like that? Let me have a quick look at what it. So no cycles. Okay, I should call it cycle. Yeah, so this is what I call a tree in the sense that there is no loop, obviously. Although you can argue that if it is a directed graph, that yeah. I think that the word tree is correct. Question, what is the structure of this graph? Is it a tree or can it have, let's call it cycles? No. So I didn't even understand my question. What the fuck? No, I mean, it doesn't make sense to continue reading because would it arrive back at the exact same position? No. If I have a cycle ignoring the direction of the edges, then we move backwards at a certain point. You can definitely arrive at the same position. If the answer is no, then that must have to do with the rules of chess and the fact that it ends in mate. Not a fan. I never seen an AI given a reasonable answer. This is bullshit. Okay, let's tell it that it is bullshit. I think the reasoning here is near impossible. And the best way to say yes, it is possible is by giving an example. So what you want is, it's probably possible, I think. But I can't quickly think of an example, so... okay, I have thought of an example. There are trivial examples you can think of. And the AI keeps it's telling me that it's not possible. No, this is nonsense. The label is the number of ply. This is also nonsense. Those things are so incredibly stupid. The only thing they can do is talk like they know what they're talking about. Optimal play means that black makes a move, causing white to need to do the maximum number of moves. But obviously you can do a stupid move, so white can mate you immediately. That's not optimal. And here it says that it's a red herring because a mate and X means that in the end black loses anyway, so black might as well do any move. No, he resists. It doesn't move, so it takes as long as possible. That's a given. This is just bullshit, as expected, so I shouldn't get excited, but... Yeah, if it's very hard, then I should say, sorry, this is above my capacity. But it says, you know, it gives you the conclusion. No, you don't have to go to the doctor. There's no problem here. It's very confident in what it says. While what it says is just nonsense. I can see that. This AI, if it was a tiny little bit more intelligent than a 3-year-old kid, would be able to see that too. It should know that it is nonsense what it is saying. Yeah, and then you get the grammar, you know. The grammar leads it to use words as rigorous analysis. It's just bullshit. It didn't do any rigorous analysis. It didn't do any analysis at all. Well, it's something that looks like analysis, but it wasn't. It is more like if there was an answer, then this would be the text that belonged to that. But the actual reasoning and the actual logic, that's kind of random. That's just fill in a few things. But it's more like if this was the correct answer, then the conclusion would read, a rigorous analysis shows that even when you blah 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 blah, the thing is so stupid. Okay, I'll just come up with the trivial position, as I said. Yes, black has to be mated, then no, it doesn't matter. Let me create a position in which this is the case. Board editor, clear board. Now, like this, for example. I forced them to make it trivial. Black is just only one move. Every move, you can only move the king. And we can give mate by moving then we have to use the knight to give mate here. Okay, it's not that trivial because the knight must go here and then I can't give mate. Yeah, maybe we can just put a rook here. We can check. No, that's not a good example. The image. Oh, I don't have this square. No, this one is way closer than that one, but I need this knight for that square. So this might work. If you would move this knight, then the king just walks away, which is quite annoying. So in order to bring this knight over there, in order to have that square, we need to go through this square. Because all that. Answer it later. So if you move this, it's gonna take too long. If you want to have the knight go there, then you can go through this square or that one. But going here means you need to do like yeah, 1, 2, 3, 4, 5 moves. And if I just move the king, it's kings 1, 2, 3, 4 moves. So the fastest way is to move the king first, or move the king and then move the knight there. That was my idea, but then I can't give mate. I need a way to be able. I need a way to give mate as well. Then after I did that, just so this is just a story for getting that square, and then the king is over here. So then we give the final blow. And I thought, well, I can do this from here if I pin. Let's say we pin the bishop or something, but. If I pin the bishop, then giving mate by taking the bishop is a lot faster. Do it like that, so maybe like this. Can go here and give mate, but he just takes it. So I would have to, let's say, pin this pawn. This would work. I can't go here because he just takes it. I can go here, but only after I move the king. And the knight. So I can't do it very quickly. I think this works. This looks good. Okay, so what to play? Let's say analysis board. Shocking. You have to move the king. Why? Where's this knight going then? So my idea was 1, 2, 3, 4, 5. And it's made an 8. Why? Maybe because the king is on the wrong spot. Nope, no, must play king e5. Why? Knight e3. Okay, this is what I wanted. So you can choose between knight e3 or a king move. But king e5 is faster. Okay, I want to see that one. So do king e5. No, there's only one move. What? It's going to walk with the king? You gotta be kidding me. King f6 is faster. King a8. Where is the king going? e7. Oh my god. Knight a6. Oh, right. Yeah, well, that's a bit too brilliant. Yeah, it's a good puzzle, man. White gives mate in 5. Holy shit. I have to store this one. I just made a brilliant puzzle. Yeah. So the only move is the only move to mate in 7. The only move is the king to that side. This is the only move. There's only one move. Go there. There's only one move. Go there. There's only one move. Go there. Yep, there's only one move for mate in 3. And now again only one move for mate in 2. And unfortunately now we have 4 different moves. Shit. But yeah, I could make this a pawn maybe or something. The knight of course is interesting to make it difficult. If I would put a rook, a black rook here, then I have to move it over here. But yeah, it's probably going to interfere with the rest. Anyways, let's just make this impossible by putting a pawn here. And now it's made in 7. You have in many ways. Yes, is this going to take the pawn now or something? What the F? Yeah, he's just taking the pawn. Oh, he's going to promote. Yeah, okay. Yeah, we don't want that. Now we have made an 11 in many different ways. Okay, that's not enough. It must be also end in the same position, of course. Now black can do absolutely nothing. So if 2 of these lead to the same mating position in the end, then I proved my point, right? For example, this one, and then of course the knight first. Black can move the pawns now, actually. This is not mate. We're not done yet. She's not giving the moves. Okay, let's see. So I can do this, and then he has to do that. And then I can do this. Let's stop black from moving those pawns. Surely I can add a pawn here and a lot of black pawns. And now in a way that I can give mate faster by promoting my white pawn. No way. Yeah, it's even possible in this position. Oh, no, help. Oh shit. Tried with 3 pawns. Yes, made in 12, starting with the knight. Yeah, made in 11. Pawn a3. This is a3. Oh, a three pawn. This. Well, possible. So this one could have taken from here, and this one could have taken from here. So these two pawns, I just came to that file. Yeah, up. I guess this one is simpler than the board editor. Yeah, this is way simpler, of course. So you can move the pawn and then the king and then promote. Or you can move the king first and then the pawn and then promote. Now, optimal from the given position. So from this moment on, black does not move. Black does not do a move, because of as a result of which white can give mate faster. But it will help me to reach the same position, because that's just part of the graph. So in this case, I think this situation is correct. So either we move the pawn, and then black is only one move, and then we move the king, and black is again only one move, and then we promote to a rook, say. There's a mate, yes? Now remember this position. And that was starting with the pawn. Now we're going to get the exact same position by moving not the pawn but the king. Now black does not do something wrong but it doesn't even matter where it goes to. You can go here. I give check. Now there's only one move, and then I get a rook again. This is the exact same position, but I followed a different path. So it is possible that white can choose between more than one move, just two different moves, that lead to the exact same mating position under optimal play of white. Well, in this case you could promote to a bloody queen as well, but that's just another option then. It's also not a problem for the question. Cool. That's a made an example. Well, I will be impressed if this example actually works. I don't think this will lead to the same position if I read this, but okay. This leads to position. That's a different position. Okay, but now he makes it the same position. Yep. So this is the example of the AI. Yeah, I guess that you can take. So this is made in 5, but you might as well do this instead of the king. And now it's made in 4. So let's say it goes here. And then we can play, for example, this one. And you can choose again. Made in 3. This pawn is very annoying. Yeah, I suppose you can reach this position in many different ways, right? We did take here eventually. So we can also first move the king. No, sorry, not that one, this one. And then you have the same end position. Okay. I'm not convinced. I mean, it just more or less states that this is the case, and I understand if there's no commuting plan-ish, then you can't commute anything, but I'm not convinced. So yeah, I would say it's still possible, but I'm not presented with the hard logic that makes me say, indeed. Although I can also not come up with anything. I guess I'll just have to brute force that as well. I'm going to do something else. I've been streaming for almost 3.5 hours. I'm going to go eat something and stuff. Maybe I'll be back later. No, I didn't. I know only very few languages. I did a few different languages when I was young, but that was very far long ago and stuff. I mean, I did a week-long Fortran and 2 weeks Java, I think, and I did a few months, I think, Pascal at some point, and I did several assembly languages, several forms of BASIC. And then I know, of course, Bash and SED, if you can call that a language. But yeah, that's all decades ago that I did that. It's probably not relevant anymore, plus I forgot it. So all languages to begin with. Once I became very good at C++, I never felt any urge to learn a new language, not even Python. Can you imagine? I would rather write anything in C++ than learn a new language. Yeah. Hi, post. I'm going to eat, right? That looks like Fortran, or is it also basic, maybe? I don't know. Oh, that's basic. Yeah. They use a single equals key, so what is equal sign for equals? Can't remember. Holy fast. These are all the positions that are made on a 8x8 board, except for the position where you use the edge on this side or this side. Right. Okay, so if we store all of these in, well, currently I have them in a vector. And then for each position, I would have to find all positions that can reach this position in one move legally. So in this case, the rook must come from any of these squares. That's the only legal way. And yeah, trivially, that is then not one of the positions that is made that we just generated. So also the made in one positions can be rather trivially generated, really. But in the end, I'm going to have a lot of positions, and then we generate positions that can reach that position. But that position then is not allowed to be one of the positions that I already had. So we are going to have a lot of positions, and we're going to have a single position, and then I need to find out if that single position is already stored. If we already have that. I think the fastest way is simply do a compare, but then with all of them. Once you have a lot of positions, you probably have to do a tree search, right? Binary tree. I can make the compare extremely fast. You can store the whole board in a few bits. Like 1 byte per piece, so 3 bytes is enough for a board of 256 by 256. I'm never going to do larger than that. That's not true, that would be 6 bytes. But still, even 6 bytes is less than 8 bytes, so it's still 1 clock cycle compare. To compare the one board with another board. But if I would have 256 by 256, that is like 65,000 something possibilities for each piece. So let's say I'm just going to do that till to the power of 3 is 2.8 times 10 to the power 14. That doesn't even fit in my memory. Let alone that I want to do a linear search for every step. Yeah. So at some point we really have to switch to a binary search. But storing... It must be sorted and so must have an ordering. I can just store them in a set, standard set, I think. Or standard map. Choose the board as the key, and then the info in the map says how many moves it is made. Or a list of optimal moves. A list of iterators that link to... yeah, the positions that you can reach from there. I like that idea. Takes a lot of memory though. So in order to store, in order to use a position, aka a board, as key in some red-black tree, we need an ordering. We need to be able to compare two positions, two boards rather. And already wrote that, but flipped is new. I think that my distance less, just the less than function, it compares this board with the board that you pass here. And that looks at the black king distance first, and then the white king, and then the who is to play, and then the white rook. How do I add the flipped boolean in here? Now, the distance for any of these is just the distance less called on the position of the piece. For all of them, I think. So this is the black king. This is the positionless. Let's not look at that yet then. So this is also positionless for the rook. Of course, the other king as well. So in the end, it's just position. And positionless doing the following, and it orders by the sum, and if the sum is equal, then it orders by m. Then the sum is immutable under swapping n and m, but this isn't. So if the flip bit is set, then the influence is only here, visible here. I guess flipped must be passed to the distance less. As well then. Hello, Amon. Does this make much sense? Not really. If the board is flipped, then both the current position as well as the one that is passed belong to a flipped board. So I think that is just confusing, just lost the change. I think this should work. Flipped means that N and M, the X and Y coordinate, are swapped. So now I should be able to store a board based on the distant less in a standard set or standard map, which then allows us to find it back again. Rather, well, not quickly, but let's just store everything in a map using board as the key. And then this is I don't know, some data. Maha. So I'm going to store the whole vector in this map. Let's study what more, Elman? C++? I think insert takes a value type, right? Which is for a standard map a standard pair. You can do try and place, I think. It's like the only one that works for passing those things separately. As in, now we can. Now we have two arguments. So the first one is the key, and the second one is then, well, data, whatever. And then we'll just print that again. Auto const reference. The value, I guess. Data. That it gives us, this runs over all the value pairs, and then the first one, with the value pairs are, like I just said, a standard pair. So the first one is then the key, and the key is the board, which you can print. This should work, except if I have try and place completely wrong. Let me have a look at that. Try and place plus reference. Why do I end up here? Because, oh, this is try and place. Behaves like in place. Aha. So key arguments. Okay, so data is constructed from the arguments. Well, in that case, and even a ... argument, so we can just pass nothing. No hint, of course. I'm gonna use this one, and then pass no arguments. That is at the moment, because I'm just going to default construct the data, which is non-existent yet. Not printing it here. What is that? Oh, well. Ah, yeah, of course. So we need a less than operator now, defined for board. Or a spaceship operator. Yeah, no. Let's just define a less than operator. Or actually, I don't like, I mean, I could have called this one operator less than, but I didn't. So instead, I probably just should use the compare thingy. Then a class, compare class, as it were, for the map. The map was defined in made a map, and then we can do the distance compare. Or something, I don't know, standard map. Let's look at the documentation. So a map takes a compare object, which by default is standard less key. That's what we try to use, and standard less uses operator less than. And yeah, or you could specialize it, but now let's not do that. So I'm just going to pass my own compare, and that's a functor, I guess, just a functor, right? I'm not exactly sure how to construct a thing. I think you have to pass it, aka we have to look at the constructor. Constructors, yeah. Explicit, yeah, you can pass a compare to the constructor. It's a compare followed by an allocator. Well, I'm happy with the default allocator, but just tag a compare at the end and that should work for the constructor. So it's going to be this one, I suppose. Oh, since C++ 26. Const expression since C++ 26. It's already there. So we're going to construct this thing now from a distance compare object. Well, it takes a const reference, so I should not use it temporarily there. That wouldn't work. Let's make a distance compare here. Distance compare object. It's nonsense. I think it's not using it. You just pass it to determine that type. Pretty sure of that. See, they do it here as well. The default is even a temporary. It's extremely dirty. I wonder if it knows that this type must be the distance compare. Nah, probably not. Gonna try passing a temporary there. So you can see that it is fine because the object doesn't even have state. It's just no state. The only thing it has is a Boolean operator parenthesis that gets two value types, I think. So in this case, board. Left hand side and board. Right hand side. Which in turn just calls a distant less member function, which I already defined. So now we can compare two boards, left hand side, right hand side, using this type, which is now part of the map. So now the map works because it doesn't no longer use operator less than. Too few arguments. Okay, something is wrong then. I need a pass flipped. What? I have two boards. How can I have to pass only one flipped? Makes no sense. Oh, because I'm looking at something completely different. Never mind. But this one also has a flipped. Board distance less. One board. Flipped. Dude. We need two flips. Why would I even want to pass that to a board? It just doesn't make any sense. Okay, let's begin with doing the sensible thing, namely removing the flipped. And the problem here is that we have two flips. Just screams that it is not the best way to code it. Did it work? I think it did. Because we just put it in the vector and then we put it in the data map and then we print the map and it printed it. So, but you also get to see the order of the map now. So it would be interesting to see in which order this is being printed. That should be the distance as defined by. Now the most important thing is the black king. Therefore, all the positions where the black king is at 0, 0 is going to be are going to be printed first. And then the white king is the most important one. And the white king cannot be here because that's next to the king, and or can also not be here. But apparently the white king prefer to go here instead of there. And the reason is that these two are both on this diagonal, which means that that has a sum of 2. So the sum is in both cases already determined, and then we prefer that it's as far to the left as possible. So this one is picked over the other one because this is at 0 and the other one is at 2. And then for the rook, we get yeah, we normally would expect the rook to be here, but these are only in a mating position. So the rook obviously has to go there then, instead of there, or there, because it's simply ordered by this coordinate, as far as possible to the left again. So indeed, then the next one has shifts the rook further and further, till we are at 7. And then the king is moved to the next diagonal. And the rook again moves that way. Yeah, and that were all the mating positions with the king in the corner, apparently. Well, that's not true. You can also give mate from this side. Oh, what? Going to assume that those positions are simply missing. That's not good. Yeah, they are missing. Aha. So the flipped version does not exist because the king is on this diagonal. And I never generate specifically for an M coordinate of the rook. You have to add that in. So I'll do that first and then check it further. So these are the special cases for the black king being in the corner. And this is the white rook coordinate, N, yeah. Maybe, so it's N or M now. So I'm just, let's call it C, whatever. For coordinates. Substitute white rook, N becomes white rook coordinate. And then we need to do the mirror, meaning we just swap these two, right? So this becomes 2, 0 and 2, 1, and these become 0, that, and again 0, that. Now that immediately is preferred Okay, so what I said was just wrong. It prefers M to be minimum. Yeah, that's what I remember now. So the king is preferred actually on 0. Not this 0, but that 0. Ah. And then the rook moves down. And then the king prefers to stay on this diagonal than going to there. So yeah, that's correct. Now we get this one. And then we get this diagonal, but as low M as possible for the king, and then the rook goes down for all those. And then the king goes here, also correct. And then now finally we have to move the black king. No, the black king goes there, which is interesting, because I thought it wants to go to this diagonal, but it should minimize M. To the right? Should have gone there, the black king. But okay, the problem here is, of course, it is flipped. So internally, the black king is actually on 1-0, which is the same as this one. Why does it order this one before that? That's puzzling. We get one of those. Immediately after that, the king goes here. It seems to be alternating between flipped and not flipped. Doesn't make any sense. I don't see the logic in it. But yeah, okay, I'm gonna quit. I'm going to eat, that is.